Let's take the derivative of a to the x times the arcsecant of x to the b, where a and b are constants. Good first step will be differentiating both sides with respect to x. So, dy, derivative of y equals d dx of, copy and paste this, and it looks like we have a function, a to the x times another function, which is arcsecant of x to the b, so we can break that up using product rule. So let's do that. So d dx of a to the x times arcsecant x to the b, fix that parenthesis, plus a to the x times the derivative of arcsecant of x to the b. And we can begin to take these derivatives. So the derivative of y is equal to the derivative of an exponential function is going to be a to the x times ln of a, and we're still multiplying that by arcsecant of x to the b plus a to the x times the derivative of arcsecant of x to the b. Well, we have an x to the b function nested inside, x to the b is nested inside the arcsecant function. So let's take that derivative over here. And I'll just copy and paste this over here. So the derivative of arcsecant b, we have a nested function, so we're going to do a u substitute, or we're going to do a chain rule. So u is going to equal x to the b, and then we need to rewrite it. I already have it here, and I'll just rewrite this inside as u, and then we are differentiating a function that's in terms of u with respect to x, so we're going to have to chain rule now. So du dx times d du, arcsecant of u, and u we can find first. We have du dx, we can find the derivative of u first, is equal to, using the differential power rule, we have bx to the b minus 1, and we can write that here, bx to the b minus 1 times the derivative of arcsecant u. Well, we already worked out in the main derivation video for arcsecant that the derivative of arcsecant is going to be, it's a positive one. It's going to be equal to 1 over u squared times the square root of 1 minus 1 over u squared. And we can undo the u substitution, which we said is x to the b. So we have x to the b. And x to the b squared is going to be x to the 2b. So let's rewrite that. And this is the same value, so we can replace u squared here with x to the 2b. as well. Bx to the b minus 1 times 1 is going to be just equal to bx to the b minus 1. So we can combine these two, make that multiplication. And we have this derivative now, the derivative of arcsecant of x to the b. So let's bring that right up here. And let's see what else we want to do with this function to clean it up. The left side is looking pretty good. Let's see if there's anything that we can cancel out on the right-hand side. Is there anything that we can do with x to the b minus 1 over x to the 2b? So x to the 2b is the same as saying x to the b plus b. Just clean this up. And x to the b minus 1 times x to the minus 2b is equal to x to the b minus 1 minus 2b. So yeah, it looks like we can do something. X to the b minus 2b is just going to be negative b. So we have negative b minus 1. So we can write that in the denominator as x to the b plus 1. So we have x to the b plus 1 and get rid of x in the numerator. And let's clean this up because we're nigh on finished. Is there anything else that we might want to do? Well, let's bring the ax into the numerator. So we have a to the x times b. Bring these things together. And it looks like we're about done. So here we go. This is the derivative of a to the x times arcsecant of x to the b, where a and b are constants.